Namaskar, my dear friends. Let us talk about how we can switch on and switch off an LED using a MOSFET or a transistor. These kind of circuits are predominantly used in, like most of the circuit designs in our industrial circuits or medical devices, automotives, and anywhere. So you would have seen, let us say we have an LED and we are driving this by a transistor. What happens is we may require a high amount of current, and that current is not able to be supplied by microcontroller. Let us say you want to connect directly a microcontroller with one resistor, and this is one LED. So the current that will be flowing through this may not be able to supplied by the MOSFET GPI, microcontroller GPIO. So in that cases, what happens is we try to drive this particular LEDs through the power sources, and we use enable signal as the microcontroller. So if you talk about transistor, we need just 0.7 volt to enable the base to emitter, right? So for that I have just used 1 kilo ohm 1 kilo ohm voltage divider here, and this is a 3.3 volt signal that is going to come from microcontroller or any other driving signal, or maybe even power supply also, not a problem. And as soon as this power supply appears here, this particular LED will start glowing. Okay, so this is using NPN transistor. Same thing can be achieved by a MOSFET as well. So in MOSFET, what you do, basically you have a enable signal, or like this enable signal must be more than VGS. Okay, VGS TH, like threshold volt, it must be greater than the threshold voltage that is needed to switch on this particular MOSFET, which is around 2.2 volt or something. So it must be more than that. I have just used a gate resistor so that like it will help in charging the gate capacitor. Okay, and this particular LED will start glowing as soon as this voltage appears. So why don't we see both of this circuit in the multisim? So as you can see here that we have a power supply. If you want, you can drive this by 3.3 volt also, not a problem. And this is the limiting resistor that we are going to use. That is our collector resistor. Okay, that collector node is there. And this is my LED that is connected in this series, and this is going to be the driving signal or input voltage that is going to drive this particular transistor. So even if you have 1 volt signal, it will be able to drive it, because we have given you some videos in that 1 volt signal also can drive this, 1.8 volt also can drive this. For that purpose, you need to remove the voltage division. You have to have an like ample amount of voltage level, or like the current that is needed to switch on this particular base. So if you run this, what is going to happen? This particular LED will start glowing. So let us say we are going to make it 0 volt. So once it is 0 volt, this LED will not glow. Let us run and see. So you can see this LED is 0. Understood? Similar to that, if you make it 3.3 volt, then what will happen? It will start glowing. Even if you give 5 volt, not a problem, because 2.5 volt will be enough. Okay, 5 volt means here it is appearing 2.5, which will not be a matter for this particular transistor. So still it will glow. Understood? Why don't you do the same thing by replacing this transistor to a MOSFET? Okay, so what you can do is, I have taken one more circuit. Okay, so in that, what I have done is, I have a driving signal, or maybe like gate voltage that will be required to switch on the gate, and this is the LED that is connected, and same way we have connected the limiting resistor and power supply. So what we can do is, if you run it, you are going to see my LED starts glowing. Now you disable this voltage, let us say make it 0 volt, then it will start off. Okay, so once you enable this, this will start glowing. Once you disable this will start like switch off. To make it permanently, let us say switch on switch off, what do we do? Can we do one thing? We will put one component, power source, which will be my signal voltage source. So let us say we are going to put some signal voltage source in terms of pulse voltage. Okay, so like make it high or make it low, something like that. So we are going to do that. Now if you do this, you are going to see zero point 0.5 millisecond it will be on and 0.5 millisecond it will be off, and we have 1 volt plus minus. So for this I am going to change this particular source. I am going to change this particular source. Let us say initial voltage I will keep 0, final voltage I will keep 3.3 volt, and since pulse width I will not be able to see 0.5 milliseconds, I will make it 500 millisecond. Okay, and this is 1 second or 1000 millisecond, like half of the period it will be off and half of the period it will be on, and that's all. So this is my power supply that we have configured. Now half of the time it will be on, half of the time it will be off due to this particular pulse source. So let us run it. So you can see the LED is blinking at a continuous rate of 500 millisecond. If you want to reduce or increase the like rate of the blinking, you can, let us say, make it 1 second, and let us make it 2 second or 1.5 second I'll make. So what will happen is 1.5 second it will be 1 second it will be on and 0.5 second it will be off, like half of the period it will be off and twice it will be on. So you can see on is more time, off is less time. So hope you have enjoyed this, how to drive an LED through a MOSFET or a transistor by very simply giving your input signal or varying your input signal. So if you do have any questions regarding the LED driving in a circuit design simulators, you can put down your questions in the comment box and we shall be able to answer you out. Thank you.